In this set of problems, we're asked to use L'Hopital's rule to find the limits. And remember, in order to use L'Hopital's rule, we first have to use direct substitution and make sure that we get a result that is in one of the indeterminate forms. So for these four problems, that's 0 over 0, or plus or minus infinity over plus or minus infinity. Now let's try these problems using L'Hopital's rule. Okay, and then hopefully you can confirm these on your own using methods that you used in Chapter 2. So you could either use numerical methods or graphs or algebraic methods to confirm your answer. Okay, so the first one is limit as x approaches 4 of x squared minus 16 over x minus 4. We're going to try direct substitution. Remember, direct substitution says you just plug in your values of where you're taking the limit. So I'm going to plug in 4, and if I plug in 4, I'm going to get 16 minus 16, which is 0. And if I plug in 4 in the denominator, I get 0 over 0. So we can apply L'Hopital's. So L'Hopital's, which I denote this way, and if you put that on your test, it'll help me to see where you try to use L'Hopital's, tells us that we can, this is equal to, so that's not right? That's our indeterminate form. That this limit is equal to the limit as x approaches 4 of the derivative of the top, so 2x, all over the derivative of the bottom, which is 1. And once again, don't try to use the quotient rule. This is different than the quotient rule. It's just saying take the derivative of the top function and then take the derivative of the bottom function. So we can try direct substitution again. If I plug 4 in there, I'm going to get 8. So that's my limit. And again, confirm this. Well, we confirmed this earlier when we did the algebraic manipulation with this and canceled the x minus 4 factor, and we got the same answer of 8. Let's try the second problem. If I use direct substitution, I take the sign of 0, I'm going to get 0 over 0. So that is indeterminate form, so I'm going to use L'Hopital's, right? And I'm going to take the limit as x approaches 0 of the derivative of sine of x is cosine of x. And the derivative of x is just 1. So now when I use direct substitution, the cosine of 0 is 1, and the bottom is just 1. So I get the answer 1. Again, you might want to look at the graph of this function to see that our answer agrees with what you're seeing on the graph. Let's try the next one. So if I plug 0 in directly, I get cosine of 0 is just 1, minus the sine of 0 is 0. And so that squared is just 0. So on the top we get 0. No, excuse me, we get 1 over 0. Sine of 0 is just 0. So this is not in the indeterminate form. So we cannot use L'Hopital's rule with this problem. Cannot use L'Hopital's rule. So we would have to resort to one of our old methods, and we can use the graphical approach, graphing it and looking at what's happening as x approaches 0, or you could use the numerical approach, and I'll allow you to do that on your own. All right, so the next one is the limit as x approaches 4. If we plug 4 into this function, we get, so try direct substitution, we get 2 times 16 minus 5 times 4 minus 3 all over 4 minus 4. And what do we get? 2 times 16 is 32 minus 20 minus 3 all over 0. And that's going to be 32 minus 20 is going to be 12 minus 3 is going to be 9 all over 0. And that's not in the indeterminate form either, so we can't use L'Hopital's method with that, and we're going to have to resort to one of our old methods.